Okay, so our last section in this very long chapter, we're going to be dealing with inverse sine, inverse cosine, inverse tangent, which we've kind of dealt with those already. It's when you have the sine or have the cosine, but what you're looking for is the angle. So we've done this in our calculator, like that sine -1, cosine -1. But now we're going to get kind of the official breakdown of what exactly it means. So remember what an inverse function is. An inverse takes all the x's and y's and totally swaps them. So when you're looking at a graph of an inverse function, it literally looks like they just kind of swapped the axes around. So you can see this sine graph, it wiggles up and down instead of kind of wiggling like this, like a normal sine graph looks like. So the inverse, here's our original function, and this is just one example. You could do the same thing with cosine or with tangent. So this is our original function, this is the inverse function. Notice what we've done is swapped the x and the y. So now you have x equals sine of y. A couple important things to point out though. The inverse, not a function. And remember that's that vertical line test that you have to pass. If I go like this, I'm gonna pass through the graph over and over and over again, especially considering the fact that it's gonna keep wiggling down like this. So the way it is right now, I would pass through an infinite number of times. And basically the way that the inverse function works, so let's back up to the original. The original, I plug in an angle. I plug in an angle and it gives me the sine. So say for instance I plug in 30 degrees, the sine is 1/2. You do the opposite with this. You plug in the 1/2 and it gives you the 30 degrees. But there are many, many other places that would have the exact same sign. So say I did do like 1/2 for instance. Here's the 30 degrees. But down here you'd have another spot, up here you'd have another spot, it would cross over and over and over again. There are an infinite number of angles that have a sine of 1/2. And if you look on our unit circle, you can actually see, here are two right here. 30 degrees has a sine of 1/2 and 150 degrees has a sine of 1/2, which means if you keep going around, they're gonna come up over and over again. So this would be 390 degrees. And if you add 120, this would be 510 degrees, and you would just keep hitting it over and over and over. And you could also go backwards and you'd hit it over and over. So what we need to do is we need to restrict our domain so that when you plug in 1/2, you know what angle it's supposed to give you. So my domain cannot include both of these quadrants, because I've got two options. So here's a positive 1/2. So my domain can only include this one quadrant right here, and we're also going to include this quadrant down here where the sine values are negative. So if I plug in a negative value for sine, it's gotta be somewhere in this quadrant. I cut out this option. And if I plug in a positive value for sine, it's gotta be in this quadrant. So I want basically the right-hand side of my circle here. So instead of saying 0 to 90, and 270 to 360, I'm going to call this -90 and then go all the way up to 90. So that is my restricted domain. Let's fill in some things here. So arcsine, that is our inverse sine function. So we can write it in two different ways. This is the way you're used to seeing it, like in the calculator, sine with the little -1. You can actually also write arcsine. That's the exact same thing. So arcsine of x. The calculator does this, but you could see either one of these in the book. The domain, if you look from left to right, the farthest value left is a -1, the farthest value right is a +1. So the x values go between -1 and +1. And then for our range, we're going to restrict it down. Okay, so as long as we go from just here to here, the graph doesn't cross back over itself, so going just from here to here, it would pass the vertical line test. And this is the restriction that I was talking about on the unit circle. I want to go from -90 up to +90, and that's it. Okay, or in radians, which is the way it's marked on here, -pi/2 to +pi/2. Okay, so that's sine. And let me show you the unit circle one more time. If I restrict myself only to this side, because remember what I'm doing is I'm plugging in a value of sine. If I plug in √2/2, I want to make sure I know that it's this angle, not this angle. So I restrict down my domain. So now let's look at cosine. If I plug in like √3/2, for instance, I want to know that it's this angle, not this angle. because these ones are both the same. So in this quadrant we have positive cosines, in this quadrant we have negative cosines. So if I plug in a positive value, I want to know it's in this quadrant, not this one. And if I plug in a negative value of cosine, I want to know it's in this quadrant, not this one. So I'm going to do the top half of the circle from 0 degrees to 180 degrees. So let's write that down. So here are my symbols. Y equals cosine inverse of x, that's what we see on the calculator, or you could write arc cosine, that's the abbreviation. Domain is the same. My domain is the same. If you look, like the biggest value of cosine I'm going to hit is a positive 1. Then they all get smaller and smaller, and then the smallest is a negative 1. So my domain is going to be between negative 1 and positive 1, just like these values are. But this time I'm restricting from 0 to 180. Which 0 to 180 in radians is 0 to pi. Okay, now we can't reference this one anymore because this is sine, so it's not going to help us out very much. And then arctangent. Same two notations. We've got that tangent inverse is what you'll see on the calculator, and then you can also write arctangent of x. Okay, now this domain is a little bit different because picture my original tangent function. My original tangent function looked like, let me grab it. Here we go. My original tangent function looked like this. So it kind of wiggles up like this, so if you turn the whole thing on its side, it's going to keep going to the left, it's going to keep going to the right. So we're going to have all of those possible values. So the domain is actually all reals when you're talking about tangent. All right, and then the range, if you flip it on its side, we want to make sure that we're only getting one of these little wiggles. Because if you flip it on its side, it's going to fail the vertical line test just like the other one. So we just want one of these little wiggles right here. So that goes from negative 90 to positive 90, just like sine. Okay, and also in radians, there's a different definition. Same as what we had for sine. Okay, so that's just kind of a rundown of all the stuff that we're going to be doing. Okay, so let's flip and do a handful of examples here. So these should be nice and easy. Just kind of keep your unit circle with you while you're practicing these, and eventually you'll get to the point where you just have them down. So this first one, cosine inverse of 0. What we're trying to figure out here is we know that this cosine is 0, but we don't know the angle. Okay, so we are trying to find an angle with a cosine of 0. Oops. So basically we're saying like cosine of some angle is equal to 0, and the piece that we're missing is the angle itself. So like I said, if we just look at the unit circle, we want to find a cosine of 0, and cosine goes with the x value. So if you look all the way around the unit circle, this point right here and this point right here have an x value of 0. But remember, we restricted our domain for this very reason, because we've got two possibilities here, and we know we can't give two answers. So cosine is restricted to just this top half here, so it's going to be this. So the directions say to give our answer in both degrees and radians. So let's say theta equals 90 degrees or pi over 2. All right, so either one of those, both in degrees and radians. And then the next one, we're basically answering the exact same question. So we're looking for theta. This time it is an angle with a sine, because this arc sine right here, this is the inverse of sine, with a sine of negative root 2 over 2. Okay, so sine is the y value, so let's go back to our unit circle. So if we look on here, we're looking for a y value of negative root 2 over 2. That could be this angle right here, or it could be this angle right here, which is exactly why we needed a restriction. We restrict ourselves to this area over here when we're talking about sine. And now we changed kind of the way that we wrote it. We're not writing this as 315. We're writing it as negative 45, because you go from negative 90 to positive 90. So theta is equal to, we can write this as negative 45 degrees, and if we write it in radians, that is negative pi over 4. Okay, so same two options that you've got right here. Okay, a couple more. Now these ones right here, we call these triangle problems. This, we're trying to find the sine of And then tangent inverse, that's an angle, so we're going to write a theta. That's an angle that has a tangent of 3 over 8. So we've done problems like this before, where you can kind of set up your own little triangle, label theta. Theta can be either of the angles, just not the right angle. And if the tangent is 3 over 8, remember tangent is opposite over adjacent. So that means the opposite side is 3, the adjacent side is 8. And so if we want to find the sine, we need to have the hypotenuse for that triangle. So we do a little Pythagorean theorem, which we can only do if it's a right triangle. So we have 3 squared plus 8 squared equals c squared. Well, 3 squared is 9, 8 squared is 64. So we keep simplifying. So we add these two together, we get 73. And finally, square root both sides. Okay, so that is our hypotenuse. We found the missing piece. And now we want to find the sine of that angle that has a tangent of 3/8. So basically we just want the sine of theta that I labeled in here. So the sine of theta, remember sine is opposite, which is 3, over hypotenuse, which is the square root of 73. Now it says to round to the nearest hundredth, which means they want a decimal approximation. So if you were to plug that into your calculator, take that and plug it in, and what you get is approximately 0.35. It says round to the nearest hundredth, so we want 2 decimal places. Okay, next one. We want the cosine of the angle whose cosine is negative root 2 over 2. Now this one sounds easy. It is. Let me just kind of walk you through the triangle anyway. So if we set this up, we're going to put in an angle right here. The cosine is adjacent over hypotenuse. And then if we want the cosine of that angle, we just need adjacent over hypotenuse. So cosine of that angle is the adjacent over the hypotenuse. So this one actually was exactly as easy as it seemed. Cosine and arc cosine are inverses of each other, so they actually cancel each other out, and it would leave you right with that negative root 2 over 2. If you plug that into your calculator, you get about negative 0.71 if we're going to round to the nearest hundredth. Okay, now this one you can use a calculator for really quickly. So we've got tangent theta equals 1.8. Find theta. So what you do is you take the tangent inverse of both sides. Now what happens here, like I said, is the tangent inverse and the tangent cancel each other out, and you're left just with a theta. And so this is what you want to plug into your calculator, and I apologize, I of course do not have a calculator with me, but you would plug this in. This is the trig menu right next to the 7, and so you'd find tangent inverse, plug in 1.8, and what you get is 60.9. So that is one of your multiple choice options. Okay, last one is going to be very, very similar to the one we just did. You've got this ski trail here, right here, forms a triangle. Write an inverse trig function that can be used to find theta. So we want this, the angle the trail makes with the ground. So here's the ground, here's the trail. It says then find the angle. So we don't need to find this missing piece. We can find this based on the 2 pieces that we do have. So we've got the opposite piece, and then we've got the adjacent piece. So we set up tangent, because opposite over adjacent leaves us with tangent. So that is 5 over 12. Since the piece that we're looking for is the angle, what we're going to do is take the tangent inverse of both sides. So theta is the tangent inverse of 5/12. And again, I apologize that I don't have a calculator with me, but you would plug this into your calculator, that trig menu right next to the 7, and what you get, if we round to the nearest tenth, is about 22.6 degrees. All right, that is it for Chapter 12.